All right, so we're going to continue to work with our properties. Here we have some properties of radicals. The product property of a radical is if you are taking the root of a product, you can break it down by taking the root of each individual part of that product. You also could write it this way. A times b to the 1nth power is the same thing as the nth root of ab, and then you can use your exponent properties to rewrite it that way. So we've done some of this. Hopefully this looks familiar. This one, if you are taking the root of a fraction, so a quotient right there, you can take the root of the top and the root of the bottom and then simplify them separately. Um, if you are raising a fraction to an exponent, you can bring the exponent into each part of your fraction to rewrite it that way as well. So we'll use whichever one seems appropriate for the different problems we're going to simplify. So example 3, rewrite the product or quotient of a radical. So what is the fifth root of 16 times the fifth root of 8 in reduced radical form? So we saw up here that if you're multiplying radicals with the same root together, you can put them all together underneath one radical. So this is going to be equal to the fifth root of 16 times 8. 16 times 8 is 128, so we have the fifth root of 128. So can we reduce the fifth root of 128? So because this is the fifth root, let's look at our, what do we call these? Not perfect powers of 5, perfect fifth roots. I don't know what we call these. But if we look at all of our numbers and we raise them to the fifth power, we're going to see if any of these numbers that we can take the fifth root of perfectly fit into 128. And it turns out that 32 fits in. So we're going to break down the fifth root of 128. 32 fits in 4 times. Now the fifth root of 32, here's 32. The fifth root of it is 2, so that turns into a 2. And then the fifth root of 4 will stay. And that is a reduced radical of the original problem we started with. All right, part B. We're going to approach this the same way. Well, no, we're not. Just kidding. So notice this is the sixth root of 8x times the third root of 2x. We want to write our answer in reduced radical form. So let's kind of manipulate this a little bit. If we put this into exponent form, so the sixth root of 8x is the same thing as 8x raised to the 1/6 power times, this is going to be a 2x raised to the 1/3 power. And then we're kind of working backwards. If we can get this to have the same root as this one, which is a 6, so can we rewrite 1/3 with a denominator of 6? So I'm going to leave this one the same, 8x to the 1/6 power times 2x. If I multiply the numerator and denominator of that fraction by 2, we get 2/6 power. So if you notice, the 1/3 is the same thing as a 2/6. 1/3 is just a little bit more reduced, but we're going to be able to work with this 1/6 power. So if you notice, we're taking the sixth root of this term and the sixth root of this term. So we can rewrite 8x times 2x squared and take the sixth root of that whole thing. So it's almost like we pulled the sixth root out of each one. This left us with just the 8x, and here it left us with the 8x still raised to the second power. All right, so let's go ahead and simplify. How about that 2x to the second power? We have 8x times 2x and then squared is a 4x squared. That whole thing is being raised to the 1/6 power. We can multiply those together. We have 32x to the third power raised to the 1/6 power. And then we can put that back into radical form. That's the sixth root of 32x to the third power. Can we do any reducing with this? So because it's the sixth root, 1 to the 6th power is 1. 2 to the 6th power is 128. So we're just getting numbers too big. So we can't simplify a 6th root of 32. Can we simplify the 6th root of x to the 3rd power? We would need at least an x to the 6th power. I think I just said that wrong. Can we simplify the 6th root of x cubed? We would need this to be raised to the 6th power in order to do any reducing with that. So that just means we're done. Can't reduce that anymore. So there's our final answer. All right, what is the cube root of 2n over 9m in reduced radical form? So we're going to take the cube root of the top number, or of the numerator, over the cube root of the denominator, and let's simplify this. So what do you guys think? Can we have a radical in our denominator down here? We cannot. We have to rationalize. You guys have rationalized before by multiplying a square root by itself. That rationalizes your denominator. But what do you do if you're not dealing with a square root? So what we want to focus on is the fact that this is a cube root. So let's look at our perfect cube numbers. 2 to the 3rd power is 8. 3 to the 3rd power is 27. 4 to the 3rd power is 64. We need to multiply this by a cube root of something, and we want to end up with something we can cube root perfectly. So I want an 8, a 27, or a 64 under this radical. So does 9 fit into any of these? 9 fits into the 27, so we want a 27 right here. Well, what do we multiply 9 by to get to 27? 9 times 3 is 27. So we're going to rationalize with a cube root of 3 to get to the cube root of 27. Now we want the m's raised to the 3rd power because the cube root of m to the 3rd power is just m. Well, right here we have an m to the 1st, so how many m's should we multiply it by so we end up with m to the 3rd? We're going to multiply it by an m squared. So it gets a little bit more challenging when you have to rationalize radicals that are no longer square roots. So we're going to multiply our denominator by the cube root of 3m squared, which means you have to multiply the numerator by the cube root of 3m squared, the same thing. We already figured out what the denominator would be. 9 times 3 is 27. M times m squared is m cubed. We're going to be able to take the cube root of that perfectly. Our numerator, if you're multiplying cube roots, you keep the cube root. Multiply 2 times 3 is 6. And then n times m squared is just m squared n. All right, we can't do anything with that cube root of 6m squared n, because if we look at our perfect cube numbers, do any of these fit into a 6? Nope, 6 is too small. And then you have to have at least an exponent of 3 with your variables to be able to simplify it. So that's done, but our denominator, cube root of 27m cubed, what's the cube root of 27? 3. What's the cube root of m to the 3rd? M. And that's how we are rationalizing denominators that have roots other than a square root.